Today we're going to go over graphing absolute value inequalities and also writing an absolute value inequality if we already have the graph. So to start, we're going to decide what's happening to the vertex. So in this first example, I'm looking at the -3 here in the bars. So that tells me that the vertex is going to move right 3, and then the +4 tells me that it's going to move up 4. So if I plot that right there at 3, 4 is going to be the vertex. Then I'm looking in front at the a value, and I see that a is 2, and the negative tells me that it's going to open down. So the slope is going to be -2 on the right-hand side. So we'll go down 2 over 1. And just so I can be consistent, I am going to plot all the way out. Then I'm just going to mirror on the other side. Now with inequalities, there's also shading that's involved. And so first off, notice that I'm drawing a dashed line. So the reason I'm drawing a dashed line is because there's no line underneath the inequality. If there's a line underneath, then we know that the line is solid. So here it's dashed. And then for the shading, this is what you need to do to kind of make things easier on yourself. Put your pencil anywhere on the absolute value. So let's say I just put it right here. I'm going to ask myself, where are the y values less than this graph? So I'm saying less because that's what the symbol is. And then I say to myself, okay, well, y values get smaller as I go down. And so then this would tell me that I need to shade under the absolute value. And then that right there would be the answer. On the next one, I'm looking in the bars to see that I need to move left 1 and down 2. So there's the vertex. The slope is 3. So we go up 3 over 1, and I'm going up since it's a positive a value. And then I'm going to mirror that on the other side. When it's time to shade, I'm going to put my pencil anywhere on the graph, say right here, and I need to shade where the y values are greater. So y values get greater as you move up, so that means I'm shading inside once again. Now the other thing we need to be able to do is write the inequality. So when I write the inequality, I'm going to have y first. And then in this case, notice that this is a line. It's not the absolute value. So I'm thinking about y equals mx plus b form. And so the y-intercept is right here at 5. So we'll have a +5 at the end. And then the slope is up 1 over 2. Up 1 over 2. So that's a slope of -1/2 x. Now you'll notice that I did write an equal sign here, but we would know that that's incorrect because of the shading. So I need to have an inequality symbol. When I look at this, I see that the shading is above the line. So I think, okay, well, above or up is where I would find the larger y values. So this will be a greater than. So y will be greater than. No line underneath for the equal to because I see that the line is dashed. On the next one, we have an absolute value function. So to begin this, we're going to start with the vertex. And so I look at the vertex and I notice that it has been moved to the right 1 and up 3. So when I go to write out the inequality here, I know in the bars with the x is going to be a -1 for the right and then a +3 on the outside for moving up. Then I go and I check the slope. So the slope here for one side would be down 2 over 1. And just checking it does stay with that consistently. And so that's a slope of a -2. Then for the symbol, looking at the shading, I ask myself, well, what's shaded? What's shaded are the y values that are under or below. So these are all y values that get smaller, which would mean the inequality would be less than -2 times the absolute value of x minus 1 plus 3. Again, no line underneath because of the dashed graph. Two more examples. Notice the one on the left is a line again, so we're thinking about slope-intercept form. So the y-intercept is down here at -4. This slope is up 3 over 1, and it's negative. So that would be a -3x. For the symbol, as I look at the shading, I notice that what's being shaded, like if I go to the line, I have to go down. So I'm going to smaller y values, and so the symbol would be less than, and this time or equal to, since that line that's graphed is solid. For the one on the right, we have the absolute value, so I start by looking at the vertex, and I say that vertex has been moved to the right 5 and up 3. So inside the absolute value, I'm going to see x minus 5, and then plus 3 on the outside. Then I check what the slope is. So this slope is down 3 over 1, and it would be negative. So -3 is in the front. There's the y. And then I check the shading to decide on the symbol. So put the pencil anywhere on the line. So let's say right here. And then I see that I am shading up or towards larger y's. And so that would mean this is an example of greater than or equal to. And last step. Here on this one, there's the vertex. So I can see here that we've moved the vertex to the left 2 and down 3. So in the bars, we're going to see an x plus 2 and -3 on the outside. This slope is up 1 over 3. So there's a 1/3 in front. And I notice what's shaded are the y values that get smaller or are less than the b. So this will be less than. No equal to, because you can see here that this line is dashed. It's not solid. The last one for the line, the y-intercept is 4, and then the slope is down 3 over 1, so that's a -3x, and it's also shaded underneath. So this is y is less than -3x plus 4.